I'm going to do question number 5 in the packet that I gave you today. If you're in my 5th period class, we got a good start on question 5, but my 2nd period class, we didn't start this at all, so I'll start this from scratch. This is talking about an airplane traveling at a speed of 500 miles per hour with a bearing of north 40 degrees west. So if you want to go north 40 degrees west, you start going, you're heading north, and then 40 degrees going west would be in this direction. So this vector goes into quadrant 2, and this angle right here is 40 degrees north, 40 degrees west. And because it's traveling at a speed of 500 miles per hour, the speed is the magnitude of this vector. So we can consider this magnitude and write it here as 500. And this entire angle from in standard position is 140 degree, no, it's 90 plus 40, which is 130 degrees. So then it crosses the Mississippi River and it encounters the wind blowing with the velocity of 50 miles per hour, going north 20 degrees east. So this angle with the y-axis is 20 degrees. We might not have drawn this correctly in my period 5 class. You better check this out. So this angle right here is 70 degrees with the x-axis north 20 degrees east. So what they want to know is the resultant speed. Oh, and the velocity is 50 miles per hour, so the magnitude of this small wind vector is 50. So if we want to know the resultant speed, we just add those two vectors together, which would be 500 cos of 130, 500 sine of 130 degrees, added to 50 cosine of 70 degrees, 50 sine of 70 degrees. So we'll take our calculators out, calculate those numbers. .500 cosine 30 plus 50 cosine of 70, and the x value is negative 304.3, and the y value, you just replace cosine with sine, and the y value looks like it's 430. So the question is, what is the resultant speed and direction of the plane? So the speed is the magnitude of this vector. So the magnitude would be the square root of negative 304.3 squared plus 430 squared. My calculator. I'll just go up and make sure I put parentheses. Actually, let me just delete that negative and square it plus the second one squared, and that turns out to be 526.8. So there's the magnitude. That is the resultant speed of the plane, and the direction is the arctan of 430 over negative 304.3. That's going to give us a negative number, but we know that this plane is going to be in quadrant 2 because of the negative x value and the positive y value. So I'm actually going to put the arctan of the positive numbers in there. Second tan of 430 divided by 304.3. That's going to give me the reference angle, 54.8. We'll call that 55 degrees. And 180 minus the reference angle will give us the angle in standard position. So the direction of the plane, theta, is equal to 125.3 degrees or 125 degrees. So that would be in this direction. So the magnitude of 526, it looks like the wind has helped this plane go a little bit faster once it crosses the Mississippi River. Hopefully all of my math is right, but I'm sure you'll tell me tomorrow if I get something wrong. The next question I would like to do is number 8, the 300-pound cart sitting on the ramp, inclined at 25 degrees. Assume the only force, this should say force, to overcome is the force of gravity. And what's the force required to keep the cart from rolling down the ramp? Well, let's draw ourselves a picture. We have a ramp that's inclined at 25 degrees. And we have a cart sitting on it. We'll just draw the cart as a box. And this cart is 300 pounds. So 300 pounds would be a vector that is going directly, straight, vertically down. And the force that is required to keep the cart from rolling down the ramp, well, first of all, we need to draw a perpendicular vector. And the force required to keep the cart from rolling down the ramp would actually be this small vector down here. This is 300 pounds. So that is the force. That is the magnitude of this direction, or this vector going in a vertical direction. This is what we're trying to find. We'll call that x. We're trying to find the magnitude of this small vector, which is the force that's required from keeping the cart from going down the ramp. And so when we draw this perpendicular line, we've actually created a right triangle here. Excuse me. So since this angle is 25 degrees, and this is a right angle here, this angle up here is 90 minus 25, which is 65 degrees. And when you have two parallel lines cut by a transversal, the alternate interior angles are congruent. So since this angle is 65 degrees, this is an alternate interior angle. So this angle down here would also be 65 degrees. Or you can also see that this is a right angle, and this angle right here would be 25 degrees, same as that angle. So if we wanted to find x, this force right here, we have an entire right triangle with all of the angles filled in, and we have the hypotenuse of it. So let's use the sine of 25 degrees is equal to x over 300. And so the force that's required is 300 times the sine of 25 degrees, which is 126.8 pounds. So there's a force that's required to keep this from falling down of 126.8. I'm going to have you try number 9 on your own. Number 9 is pretty much the same problem as number 8. The only difference is the numbers have changed. So you can try that one, and we'll move on. And let's look at number 11. I don't think we would ever do number 10 because it talks about the amount of work done, and that's more of a physics problem than it is a pre-calc problem. So let's look at number 11, about 2 lighthouses 30 miles apart on a straight shore. So we read this a couple times to draw ourselves a picture. So here is the straight shore. Here's lighthouse 1. Here's lighthouse 2. They are 30 miles apart. There's a ship to the northeast of 1, and to the northwest of the other. So here is a ship. I'll call this L1 for Lighthouse 1 and L2 for Lighthouse 2. The ship is 20 miles from the one lighthouse, so I'll call that from this first lighthouse. So there's 20 miles. This is not really a vector problem. This is more of an algebra 2 problem, I guess. And the ship is 15 miles from the other. And how far is the ship from the shore? So if this is the shore, we're actually trying to find this distance right here. And there are a number of ways to get that distance. But what we need to do is we need to find at least one of the angles here in this triangle, the 15, 30, 20 triangle. So I'm going to take you back to Algebra 2 because we should probably remember some of the formulas that we learned there. And if you have three sides, you can use the law of cosines to find any angle. Well, if I'm trying to find this side, I think I'd like to find this angle down here. So I can just do right triangle trigonometry. So I can do the sine of this angle is equal to x over 20. But first I have to get this angle. So if you remember the law of cosines, that's been modified to try to find an angle. I guess I'll call this angle theta. The law of cosines says that the cosine of that angle theta is equal to the opposite side squared minus the two other sides squared, all divided by -2 times the two opposite sides. And do you have to memorize the law of cosines? Probably not. I'll probably give you just the basic a squared plus b squared minus 2ab cosine of c, and then you'd have to be able to modify it to find this. So let's put this in. We're going to do actually an inverse cosine of, I'll use my fraction button so I don't have to worry about parentheses, 15 squared minus 30 squared minus 20 squared, all divided by -2 times 20 times 30. Oops. You can see what I put in the calculator there. And it looks like that angle is 26, we'll call it 26 degrees. We'll round it to the nearest degree. So now if I want to find the distance to the shore, I can just say the sine of that 26-degree angle. I think I'll just use what's been stored in my calculator though, so I don't have to round that, is equal to x over 20. So if I multiply 20 times the sine of that answer that I just got, I'll find the distance to the shore, and it looks like it's about 8.9, what's the miles away. So there's the answer to question number 11 using a little bit of trigonometry that you learned in Algebra 2 last year. Number 12 is the last one I think I'll do today. So number 12 talks about the area. If you know, here's another Algebra 2 problem. You know the two adjacent sides of a parallelogram, 6.8 and 4.5. And find the area of the parallelogram. Well, if you remember from last year, the area of a triangle is equal to 1/2 AB times the sine of the angle in between them. We'll call this theta. And this angle is 25 degrees. So this area of the triangle, of this triangle, is 1/2 times 4.5 times 6.8 times the sine of 25. But we have two triangles that are congruent. So if we multiply this by 2, we actually can get rid of that 1/2. 2 times 1/2 is 1. And the area of that parallelogram is simply 4.5 times 6.8 times the sine of 25, which is 12.9 square yards. And since the bell just rang, I guess I'm done.